to Forward Deployed. I'm super excited today to have Rohit Krishnan on. I probably first ran into Rohit's work maybe a year or two ago. He writes an amazing Substack called Strange Loop Canon, where he's exploring a lot of the same themes that I've spent my time thinking about, mainly kind of how do agents work? How do we evolve them and build them in aligned ways? But he's really pushed the envelope in ways that I'm excited to talk to him about, as far as how can we build market mechanisms into agentic systems, and how can we build enterprise worlds. So with that, I want to introduce and welcome you, Rohit, to the show.
My absolute pleasure. Good to be here, Noah.
So I think probably the easiest place to start, because I'm curious about it, is if you could give a little bit of the background on yourself. I've been reading your writing and your research and following you on X for a while now, but I don't know kind of your whole story and how you came to be at this fairly unique intersection. I feel like, of, you seem to be interested in technology and economics and sociology and AI, obviously. So yeah, maybe just kind of you can walk me through your timeline.
Happy to. I think it's been an interesting kind of trajectory, I would say. So I think one way that I look at some of the work that I do effectively is that it sits at the intersection of AI, which because I'm a geek and I love technology and I have forever, and economics because I'm a geek and I love markets and I have ever since forever. So weirdly enough, for most of my career or most of my life, I should say, like these two have sort of run parallel trajectories. So, I graduated when after I graduated from undergrad, I tried building a company, and it did sort of all right. And then sort of I tried to build another one in the markets world that did not go all right, although I ran that as a hedge fund for a little while, and that did okay. But there's this constant tension between the fact that, like, you know, technology allows you to do really cool things, but it's, at least until fairly recently, was incredibly painful to work with, and you have to work for a fairly long time before you're able to get any benefit out of it. And at the same time, economics, or is the single biggest mystery that exists in the world, right? For anybody who cares about predicting anything or understanding the world, like the world of the markets, or the world that economics opens up, is like a window into human behavior, but also like you cannot be compressed down into smaller variables very easily. You have to try really hard to do it. So I did a couple of startups. Then I did business school, like many people. Then I spent several years trying to effectively marry these two in some fashion or the other at McKinsey, where I was leading their growth tech practice. At some point, I was an investor after that for several years, sort of trying to, well, at that point, trying to invest in AI, but like couldn't tell anybody that it was AI because nobody would invest in a company that had AI in its name, at least in Europe. Um, and sort of now I'm back in the building mode. And the commonality among these trajectories is the fact that, like, these two parallel threads seem to kind of go through my life, where I really do enjoy and love playing around in the markets and understanding it, and sort of that whole world. And I really do love technology and agents. Sometime around last year, or maybe even the year before, I've always done simulations to try and understand the world. I like them. I've done them in Excel. I've done them in paper. I've done them sort of back in grad school, and like nobody liked it for a very long period of time because they were all toy, right? I mean, it's fun and it's cool, but like it's just a toy. Now, for the first time, I feel like over the last several months or maybe a couple of years, we have a substrate where you can do cool simulations and you can actually learn something, because models are smart enough and good enough that they're no longer, you know, dumb cells like in cellular automata. Anyway, that's a long-winded introduction, but I suppose that's kind of how I came to be in this intersection, as I don't know, as Will Smith might say.
One of the things that struck me over the last year or two has been how little conversation there actually is about the fact that we call these things agents. And fundamentally, the problem that we're trying to solve is a classic economic problem, right? Which is like, how do you align agents with the principles? And I sort of, I think part of what's attracted me to your work is there's a very direct connection there that I find it surprising that we don't talk about it more, I guess.
Same here. I think, what's funny? Like, I mean, as soon as I started thinking about agents, like my mind went to the point that if they are truly agents, we've had several. decades, maybe centuries worth of work trying to figure out how to make agents work for us. Like civilizationally, we live in a construct that allows us as agents to service principals or us as principals to trust agents. That's the whole ball game.
Yep.
And I used to write a fair bit about things in terms of like organizational theory and stuff like that because it is a part of the exact same question, except that the components are human agents or non human laws and constraints, for example. And now we can actually compress them down into code and run simulations across them and actually test them. It is a major blind spot, I feel like, for a large part of the AI industry writ large. I mean, and some ways I feel like it might be a little unfair because AI industry in some ways is new, extremely, and they've got a lot going on, for lack of a better word. And everybody is, it wasn't that long ago that the way to be an AI researcher was to get really good at just training, a dense model. That wasn't that long ago, right? I mean, it is less than one undergraduate education ago. So like somebody who started out learning that is now just graduating and like they've come out into a whole new world. So maybe they just haven't caught on to it. But it is staggering to me that like once you kind of come up with the definition of the word agent, you do not draw upon this entire universe of economics that exists.
Couldn't have said it better myself. So one quick question, and I really want to get into
Yeah,
actually your simulations, which is like I'm curious, and I kind of want to share my own thesis on this with you. But
do it.
you go first on why do you think that blind spot exists? Like, I mean, I guess you just offered one hypothesis there, which is just the incentives, but it feels like it goes deeper than that. And I'm curious what you think drives that kind of that blind spot between what seems like, thousands, millennia
Yeah.
of thought around this question.
I mean, one way to think about this is like agents are, despite like I'm a big believer in the fact that you're really not going to be able to build things unless you're not going to be able to build things in the abstract. You have to kind of play around with it in the real world or like test them out before you're able to come up with hypotheses. Across a majority of the like labs at the very least who are trying to build these kinds of agents in the first place, number one, they're primarily focused on solving problems that they can operationalize and understand themselves, which tend to become the problems that are high value and like easier to solve in that fashion, which is similar to coding or things like that. Where, the current approach is very similar to kind of the way that like they themselves might actually solve that particular problem, right? Like, I mean, if I want to kind of decompose some task and give it to a bunch of engineers, there's a set of ways that I might do it, or like there are ways to verify whether their work was done, etc. Even here, the taste really matters, but you can brute force the approach to some extent. So in some ways, I think my hypothesis primarily is that like the people who are building it are not sufficiently econ built enough that they think it is even available as like a toolkit that they can pull on. They do have technology as a toolkit that's available. And what they also have is this insanely cool thing, the model, which just learns anything that you pour into it. So it is in some ways easier to spend $1 billion to get the data to train the model to do something, as opposed to sort of reconfigure the architecture such that the ecology that you might develop might actually go off and learn something. I can see how the latter might just be a little sort of disconcerting, dispiriting, because you do not have the same command and control feeling of like, I did this and it did this kind of stuff. So it is it's almost like the people who are building these at the moment are not type econ build enough sufficiently to be able to do this.
Yeah, I think I agree with most of that, and I think that I guess my build on that would just be I think there's a pattern pretty well founded in Silicon Valley, which is that like you invent the future and you generally look forward, not backwards. And I think it's long been a blind spot of the technology industry to not look at there's a I think fair criticism of much of academic research that it's often sort of living in a place that might not be the most immediately useful, but there's what we find over and over again is that if you look back in time and you see the kinds of problems that people have been working on, you realize that, brilliant people over the last 70 years have been working on, any sort of technology shaped problem. And, they don't have the full answer. But I think the bias, again, well won by Silicon Valley is to not look in that direction.
It's also the fact that like technology loves having answers, the industry writ large. And economics, in a weird way, is not
Yep.
all about answers. It's about if we set things up in the right way, we might get towards some answers as opposed to like, here's the answer for a problem that you need to solve for. And the latter, I feel like can feel very not dispiriting perhaps, but like it can feel like you're letting go of your agency and letting this abstract thing actually do it for you. Whereas like that is not congruous with the way that a lot of people would think about it. It's not to say that's the only way, right? I mean, clearly you can actually develop markets in order to solve problems, etc. But then it doesn't translate into like, okay, how do we take this and apply it to problem X such that we can get outcome Y that is really good for me? As opposed to sort of, this exists in the abstract. There are some institutional rules. And when push comes to shove, as you said, you don't really want to follow through.
So let's talk about your simulations. I want to talk about the world model builder. I have lots of questions,
Oh,
but
yes.
I think probably the very best place to start is for you to explain the work you've been doing there. I have some specific technical kind of questions on how it works and why you decided on the design patterns you did. But yeah, maybe talk through some of the experiments you've been running and why generally you think this idea of an enterprise world is such a powerful concept.
Sure. So, part of being a geek for many years is that like I've seen digital twins come and go. And I've always liked them as a concept and never saw one that I liked. So that's kind of the original genesis of this, in my head at least. So I see them and I kind of go like, oh man, it would be nice if it was here. And it's one of those things where like, if you're in a company, it would be nice if all the data was updated everywhere. It's like, yes, it would be, but it never is. And you can never actually make use of anything because like you're assuming it's a wishful thinking in the first place. So I kept thinking like, listen, most of the time you can use language models to actually do certain pieces of tasks for you inside these companies, like throw in a bunch of data, try to analyze it, or throw in a bunch of stuff and say like, what should I do next? Or what those kinds of questions can be asked. But it does not feel like the models themselves don't have sufficiently wide, I don't know, distribution entropy in some sense. They like coming back to their safe, comfortable kind of answers. They're very hard to dislodge. And it feels like we're kind of not using the tool that they're meant to be used. I mean, I'm sure you can shoehorn it to do anything, but that's not the point, right? I mean, I've tried running RL to make models better at predictions of the future, and it sort of works, but it really feels like pushing something uphill. So I started having this question of like, okay, what is it that you actually are trying to do in many of these cases, and if you're in an enterprise? And in many cases, one of the key facets of any enterprise, any organization, anything in the world to a large extent is that tomorrow is some function of like things that happen today plus a bunch of actions. And this is very, Jan LeCun pilled in some sense. And I started thinking of like, okay, what does that mean, right? I mean, maybe we don't actually need to. If I'm asking what will happen next, I don't need perfect predictions. I don't need it to say like, hey, 60% chance that the oil price will be X tomorrow. As long as I get directional predictions in terms of various things that might happen. And I've had this like very long running experiment at this point in AI, especially. Like there is I think it's been 9 months, 10 months of like, I've had a model automatically predicting what will come tomorrow. And I think I've changed the base model twice in the over the last like 10 months. And it does pretty okay, at least insofar as like the baseline is concerned. And I still run it. But anyway, so this was the kind of core hypothesis in my head. And I was like, okay, what is the right way to think about it? And I landed on this concept of like enterprise world models. World models are meant to be effectively something of the form like you have state S, you have action A, and both of those things together should lead to prediction P in some ways. And we've seen examples of this, or like people are talking about examples of this in like 3D construction. People are talking about examples of this in robotics, especially because it really matters in robotics. And people are talking about examples of it in like video. And I was like, okay, those modalities are super important and interesting in the first place. But to me, I was like, no, there is a easier, richer, smarter substrate where you want to actually apply it and be able to kind of build something interesting. And that is organizations, right? I mean, the place where sort of I spend most of my time. What do I do most of the day? It's like I kind of have some world models inside my head, and people ask me questions, and I go like, you know what? If you take that action, this is what's more likely to happen. This action, that's what's more likely to happen. And then we kind of weigh the pros and cons and make some kind of decisions. So this is the setup, at least in the back of my head. And I kind of go like, okay, so is there some way that you can actually code something or like build one of these things? And so the last sort of several months, I've been trying to kind of play around and build this. Basically, that's the kind of setup. And the interesting thing is like right now I'm working with things that are I don't know, half a million x less data than like even a small LLM, and maybe like 5,000 x smaller. These are like half a million models or something. It's a tiny JEPA models, and it already kind of works, which is blowing my mind a little bit in the fact that like even at this scale, you are able to kind of set up a world, you train it, and number one, because these are small and continuous stream of data comes in like tomorrow, you can run it as a batch and train it every day
Mhm.
and update it. Number two, you can say, at this point, these are the 10 actions that I need to take. What would actually make sense? And so I've run experiments on this with a couple of public data sets, news, for example, being the obvious one, historical and present, Enron, which is one of my favorite data sets for many reasons. And like I'm running it with a couple of startups data sets as well, pulling their information in and creating like a whatever a CEO report type of thing every day where you're like, I want to be able to ask a question and say, what should I do at this particular point? And it kind of gives a response about, you know, knowing the peculiarities of the startup. Now, this effectively means that like it is possible or it should be possible to create a world model of an organization or of an industry of a world, however, in various different scales that you might be interested in, that allows us to do things that does not necessarily need an LLM. And more importantly, you can use the model LLMs for the thing that they're good at, which is you can get them to come up with hypotheses saying like what actions should I test here. You can get them to like rationalize or explain the answers that are coming out. Like you can use them where they're useful without necessarily making them the be all and end all of the whole simulation, if that makes sense. I'm going to pause because I feel like I traverse quite a bit of
Yeah, well, so I
territory,
think
but like,
maybe one place I'd love to just dig in a little more is on the enterprise world itself. Like,
yeah,
and you can take one of those examples. I've read some of the
yeah,
stuff about Enron, but the more recent startup ones, like what specifically, how do you model that world? What does that look like so that you can then do the next layer on top of it, right? So you've got the modeling exercise where you're trying to figure out, how does this company operate, right? And you're trying to
yes,
describe it programmatically. And then, if we start there and just understand sort of like, what are the components of that? Is it a ontology in the sort of classic sense, or are you sort of thinking of something different? And then how do you actually bring the model to bear on the kinds of questions that you want to ask, which is like, I imagine, it's a
yeah.
question like, is this customer going to renew or something, right?
It can be, is this customer going to renew? Is this, how should I respond to this contract? Is this like, is it time to do a release or is it time to do another X, Y, and Z on top of that, or like product strategy, those kinds of questions. Okay. So the key is effectively that like every company effectively has a large number of different streams of information running already, right? So my sort of what I do is like take a bunch of those information streams and
Just
actually
pause for one sec.
compress.
So that's like email, Slack, docs.
Precisely.
Yeah, cool.
Email, Slack, Docs, GitHub, Jira, Confluence, blah blah blah. Like there's a bunch of streams that are already like every company in some ways. If you wanna be cyberpunk about this, you can see them as like those old school movies where you kind of flow through, fly through. The internet in those days is when there had cabinets. I
Yep.
have this visual in my head of like every company is somewhat like that because you have these things. And most of the job of like management in some senses to say connect the dots between different ones in some ways, right? Like, hey, our release cadence over there or our marketing plan over here and your doc over here and your Slack, like you're trying to constantly play triage. So if you are able to turn the raw company history without man-made ontology on top, that was important to me because A, I'm somewhat lazy, and B, like I just man-made ontologies don't really scale, is my hypothesis. Maybe it's fine and it'll become necessary at like Palantir scale, but like I don't know. If you're going to start with man-made ontologies, what's the point of doing this in the first place? And then from that, you should be able to kind of create various either branch windows. It can be daily, weekly, whatever. And you should also be able to create some version of like state, which is all the data that has happened until point T the actions that you might take in point T, which might be the emails or the Slack messages that come, and then all of the future vector, what should actually come next, what is the outcome or consequence of this action. It's very noisy. So there is a little bit of effort in trying to make sure that this noise is kind of reduced in some sense, right? Like you need to build sort of structural targets from the future tail in some sense. Like what are the real outcomes? What are the curated sort of labels, or what are the sort of you can even have LLM labeled heads, which actually works quite well for many of these things. Once you have that, then
Just to
effectively you
pause you for
can,
one sec there, like
yeah.
how in your mind is that different than, isn't that an ontology at that point, or just like some level of
It
ontological?
I think if you look back, you will probably be creating, constructing, and updating an ontology for the company on an ongoing basis. The big difference in my head is like, I do not want this to be a top down ontology that defines the company at a point in time and sort of stays. Because I love ontologies. I feel like anybody who's geeky in the entire world loves ontologies because that's how we all understand the world, right?
Great.
Anything, any information that gets thrown at us, you try to structure it down into a smaller dimension and then try to understand it. That's sort of you creating an ontology on top of it. The problem with ontological approaches in my head has always been that, like, you are defining the world in a very stringent fashion. And once you tamp down all of the weirdness, then you might just lose a bunch of stuff. And even if you don't lose it today because you're really good at ontology, you lose it tomorrow because, like, the world changes and the company changes. So that's kind of the way I think about it. Like
So you're
looking
thinking about
back,
it as kind of a data first,
correct.
a data first ontology rather than an ontology where you layer the
First,
data on top of.
100%. I don't want to like sift the data into buckets as much as like the data should inform the ontology that emerges from it. And like, frankly, like I didn't think it would work, but I'm actually relatively surprised that it does because I don't know. It's like the old whatever Ilya quote or something. Like the models just want to learn. Sometimes you see these things when like you throw in information into the models and you're like, wait, this is working for you? How the hell? And this is one of those kinds
Well,
of situations.
I often say like the thing that the models are very best at is exactly this problem, right? It's like how do we take data from one format and reformat it into another? And it's like the sort of single, to me, the kind of single underlying mechanism that we keep reusing over and over again is that. So
Yep.
yeah, that makes sense to me. Okay, so we've got this idea of like you've got the sort of data first, you layer on a sort of ever-changing ontology that the AI leads, and then predictions, I'm assuming, sit on top of that.
Correct. So the prediction might be equivalent of like all of these things actually happen. The action might be, Jeff Skilling sending an email in Enron or whatever saying that they're going to have a change of strategy or publish something, etc. And the outcome, like you can score the outcome against whatever heads that you're interested in that for that particular sort of company. So this is where you can go as crazy or as sort of small as you'd like. The end the craziest you could go is to basically treat it exactly like a transformer model and treat it as a transformer model where the you effectively are getting it to predict exactly what would happen on the basis of everything. And the interesting thing here is like you don't really need to do that. And you kind of are doing more like, hey, I need to know which one is riskier, X or Y, or like X, Y, or Z, or I need to know which one exposes me to more legal risk or commercial risk. Those you can ask those kinds of questions. You can also ask questions of like, if I is this the right strategy for me to be doing if my goal is X, like to grow in this particular fashion or whatever it might be. Like you can start coming up with questions that like a CEO or a VP or whatever would actually be asking about their own businesses on a daily basis, and then get the kind of confidence rating, so to speak, that you might have had, like you might never have had, but now you can. You can ask counterfactual questions and get answers. The thing that I have discovered is that, like, if you actually ask counterfactual questions to LLMs, then I have I did this. I think I want to say yesterday or day before. I forget. I did this where like I said, okay, all of this is working quite nicely. How about I compare these to like LLMs and sort of see how they work naively? And I compared it to, I forget, some GPT model. And for the company, the startup that I'm working with, and or the startup who's using this, and for Enron, like this already works better than language models because it has better MAEs, better Briar scores, whatever. Like, I mean, you can kind of look at how well it works and it actually works better, which is really interesting because one thing that tells you is like LLMs kind of get stuck in their basins. I think that's my hypothesis as to why, right? Like you ask it a counterfactual question, so it doesn't really want to nudge out of that. It brings things back to median in some sense. It's like
Mhm.
trapped by its priors. Whereas if you kind of, its scores are also like its scores are less stable because they're not very well calibrated.
Yep.
LLMs are not greatly calibrated. Put those two things together. And like for the news ones, just to play the other side, for the news ones, LLMs work relatively well. I think partly because they've been trained on it, like the historic one. And even the model one, like they have sufficiently similar macro language that they have been trained with that like asking a question about, I don't know, oil price trajectory tomorrow or interest rates or like the risk of recession or something is something like that is so suffused through all of our language that the models have sufficient data that they have kind of learned to predict some of those kinds of things. I still think it'll break out of bounds, but at least those ones right now for the data that I've trained with, they don't show a statistically significant difference from sort of the world model that we're talking about. But the interesting question here is like, look at what we've done, right? Like there is the LLMs, we know what they require, and it's a lot of work for lack of a better word. For here, you're saying like, look, what do we care about? We care about the fact that the entire world's history unravels across these 100 event spines that exist across different tick regimes across all of these different softwares. From those, we are able to construct automatically, ideally, some series of like state action prediction pairs from them. And from that, we are able to train I did a JEPA model right now, and I did that because I thought like they were the best that I saw, at least in this particular industry. I mean, I feel like this is a moving target. I'm not, it's
Why
the first time I've ever done it.
have you tested it with a frontier model and the underlying world model data? Like, I'm not quite following why. So I understand the sort of naive experiment where you're doing it without, but like if were in the tests you did with the LLMs, were you
Yeah.
giving it the same pairs?
Giving it the same data and
Yeah.
the underlying data and saying, these are my questions. And like, I mean, these are pretty smart models. You
Yeah.
should be able to figure it out. These are the frontier models. So,
Yeah.
like, and if you're not able to do it, there's one way of attacking it where you say, like, no, no, for the frontier models, you need to sufficiently prompt them in these ways in order to elicit the answer that you want.
Yep.
And like, that's almost sort of solving the question backwards because
Yeah.
you shouldn't do that, right? I mean, I think this is one of the things that like bugs me about using like the frontier models for unknown analyses, where if you don't know the answer, then it's really hard to elicit the right methodology or process or answers from them because you have to work very diligently to kind of extract something from them. And that's really hard if you don't know what the answer is. I tried recently with one of them.
I was talking to a friend recently who said to me, he was having a conversation with a very senior engineer who was getting amazing results out of Claude Code or Codex or one of
Right.
these things. And he sat there and watched him, and you see how much expertise this very senior engineer is bringing to bear on the model. And yet they are seeing it as the model's capabilities. And I mean, I feel this all the time myself. Like, I just think there's a very interesting kind of whole thing in this world right now is, I have a kind of theory that a lot of the productivity gains we're seeing is actually just really smart people figuring out how to use these models incredibly effectively, and that the sort of train up is actually happening on us,
Right.
not them. And when we see, 6 months ago or whatever, when Anthropic started talking about the amount of code that was coming out via Claude Code, and how it was sort of, more and more was being written without humans, it's like, well, these human operators have gotten significantly better at operating
Right.
these machines, and they're bringing to bear 20, 30, 40 years of experience on the problem, and they don't even think about it, but the questions you ask or don't ask have a huge impact on the response and the outcome. Yeah, I think there's a that makes sense. It's an interesting set of questions as it relates to productivity too, because I think, what I see in that is just, the people who are getting good at operating these things are getting better and better at operating them. And it's such a crazy clip. And that's a huge reason why they're seeing the kind of improvements they are.
I mean, one way to think about this is like if you are an engineer and you know what good looks like, then you can elicit a lot more from the model. Of course, because the model, the naive way to think about this might be you're running a search across every, raw and synthetic version of data that the model has ever seen. It's not really true, but like, as a mental model. And if that's true, you should be able to get insane things from the model because they've seen it all, right? Like it's like a, I don't know, conversational interface to the entire world that it's been trained on. So you should be able to. However, the model being the model, if you don't know that, if you don't know what you need to get out of it, you will not even know what questions to ask, and the model will not tell you because it just, it's not going to say, it's not going to do the taste stuff for you. You can train that in the next version of the model such that like the default one shot gets better, but like nobody does anything one shot. I don't know. I feel like this entire one shot thing has been a huge negative for the entire discourse because like even in the original prompt engineering days, like, oh, this is the like massive cool prompt you should use. And I'm like, do you guys just use one prompt and walk away? Do you not like continue talking to the model? Because otherwise, how do you ever get to an answer? And this is the same thing. Like, if you have expertise, you can ask specific questions and like be able to probe deeper and try to get a lot more complexity elicited from it. But here, from the world model perspective, the my question is like, if we are able to create a world model which is able to get to the point of for any kind of action based on a specific state, it is able to tell you what is the predicted outcome in the dimensions that you care about, or like whatever dimensions that you actually might want. What are the future vector actually matters? That is hugely useful because by default, just by default, even at that particular stage, without it getting much better, it is a much cheaper, faster, better way to actually train counterfactuals into the model. And counterfactuals are one of the things that like LLMs are really bad at for a variety of reasons. But they frontier models still suffer from this because they like, ask them to come up with a story or like a poem or like write an economics paper. Like they pull you so back towards the median so much that it is like swimming upstream to kind of get them to kind of push the boundaries somewhere. And what you want is the exact opposite. What you want is like an unopinionated, unbiased view of like this, and this actually leads to that. And then you might decide that's totally cool. I want to take the higher risk version or whatever it might be. But like the facts and your opinion should not be commingled so much such that you're able to kind of do this.
Well, to that point and to pushing up against models, I love the market bench stuff. And I think like that feels very tied into a lot of these same ideas because I think, part of it is pulling down to the median, but it's pulling you down to the median with a tremendous amount of confidence that it's not the median. So
Yeah.
maybe can you explain the I mean, maybe just start with the idea of market bench and kind of the idea of having these models bid on their capabilities and the efficiency with which they can do it. And then, we can get into a conversation about kind of where the capabilities lie and don't lie. And then, how I'm very curious, on the tail end of
Yeah.
this, if you have any thoughts on whether this is going to get better or worse.
Maybe I'll give you the quick background about MarketBench as well. Like the hypothesis, similar to our conversation earlier on in the earlier on today, is could you like we create ever more complicated harnesses to get many models to work together to solve hard problems? Yeah, the cursor one where they're like, I don't know, put together a bunch of sort of hierarchical methods in order to them to build a browser, or like there's all sorts of different things that people are trying to do, right? Like get to a really hard outcome. And in order to get to that hard outcome, you effectively need to get a bunch of models to work together in some ways. Great. So far, so good. My sort of, I've been looking at some of those. And since before, my head is like, we've developed a phenomenal methodology for coordinating really complicated actors, which is markets. Markets work wonderfully well. And markets are nowhere visible in the AI agent ecosystem spectrum. So the question in my head was one, like the naive question in some senses, like, can we actually get the agents to act in the market together such that we can actually sort of go more hands off? Like, if you want the agents to work in an open ended fashion on really complicated questions, then you need to be able to throw them a problem and step away. Because if to our previous thing, like if you're standing there kind of hand fiddling and pushing them, then you're not really stepping away, right? I mean, you're at that point, you're at sort of you're standing guard. So you need to kind of step away. And like at that point, I started doing some experiments to try and figure out like, okay, if you create even a naive market where every model just like bids for a task or a subtask and it kind of does it, and if it doesn't do well, it loses money. It's like that old Drew Carey show, is like the points don't matter, but like the points matter. It's one of those things for the models. You give them some objective thing and have them bid for it, do the task, do better, do worse over a period of time. Does that help? That was the kind of hypothesis that I was testing.
Just to
And
pause you for one sec, just I
yeah,
want to because I thought the bidding mechanism was clever. Can you just talk about the specific bidding mechanism? Because I think it's worth it. It helped me wrap my head around the whole idea and take it out of sort of being abstract.
every model gets a vision, or like every model gets an explanation of the task that it needs to do. So there's a benchmark auction, and then there is a scaffold routing auction. It's set up as an auction effectively, right? Like, and in this particular instance, the model needs to say what is the probability of success I will have in being able to solve this particular problem. And the model needs to say, this is the expected token cost that will be there based on my actually doing the problem. The hypothesis here being that like the models need to be good at kind of if the models are even somewhat good at judging these kinds of questions, even directionally, you can create a break-even logic where the model thinks, you know what, it's not going to take like too many tokens, and I think I'm pretty likely to succeed. So I should bid high because I should be the one doing this task. Whereas if it's like, man, I'm going to use so many tokens and I don't even know if I can succeed, then it should bid low, right? Like, I mean, that is the kind of hypothetical question here. Now, this relies quite dramatically on the model's self knowledge, which is kind of one of the first pitfalls that we kind of fall into. The models, including the frontier models, including the top ones, are really bad at knowing what they're good at. Like, really bad. Which is, I mean, I thought they were bad, but I did not expect them to be this bad, quite frankly. And part of it is just that, like, so their bids rely a lot on their internal conceptions of themselves. So, I'm anthropomorphizing them a little bit because it's fun, not because it's true. But like Gemini, for example, wins is overconfident all the damn time. It is beautiful to see. Like, it is so overconfident that it can win everything. Like, you throw any problem at it, it'll like just bid because it knows like it can win. GPT, weirdly, underconfident. Like, is not sure, like maybe I can do this, maybe I cannot, whatever. Claude was the better one amongst those three, but it's not to say it is good because all three are bad. So none of them are good at calculating or understanding or knowing what the expected token cost is likely to be. I think they're off by like orders of magnitude as opposed to sort of, a little bit over or under. Now, this is the then, and like I wrote this up as a paper with Andre, and like we did a bunch more follow-up experiments. But like what Andre and I did was we set up this set of questions which is taken from SweBench, like software engineering, whatever. We had a bunch of questions, subset of questions that taken from it, same harness. We gave it to the one model, multiple models randomly assigned, and a bidding based market kind of mechanism. And the question in some sense was like, who actually would do better, or what would do better, and where would it do better. And the interesting thing is like, even with this sort of fairly naive setup of just get the models to bid, like you're start to be able to see that like for many different things, for many different types of questions, the models do better in this fashion as opposed to needing some hierarchical kind of approach where like top down you say these are the decomposition, Opus you go do that, or like GPT you go do that, etc. Some of the answer is just because model diversity matters. Like if Opus fails, it is better to give the next try not to Opus again, but like to GPT or
Mhm.
Gemini. It just seems to help. But some of it is also that like, it is a way to shake them out of their internal like basins perhaps, or like it is a way for them to even at this level, even without self knowledge, collaborating with each other does seem to produce better outcomes, which
Mhm.
is like a massive win for markets in my view. And like it, I genuinely feel some version of this has to be built into the next generation of the models such that they learn what they're good at and they're able to bid better. Because if we want the models to work on truly open ended tasks, they need to be able to do this. because
Yep.
they can't just wait for the next instruction or create a cron job to do a whatever, poke them to go do something. Like these are all like workarounds, right? I mean, you do need them to independently look at a set of things and say, I will do this, and someone else say, I will do that, and you start seeing this emergent ability of different things actually work.
I know it wasn't the purpose of the experiment, but did you play at all with layering on prompting and other data sources to help it become better at its own self-knowledge?
Yes. So one of the results we ran effectively, one of the later tests that we ran effectively gave the models a lot more information about their prior successes and failures, not from even from external world. Because bench results exist. So like you can kind of read them and kind of give the model more self-knowledge. It does help directionally. It does not solve the problem. So purely with prompting, and you give the model a bunch of information saying like, dude, don't be so overconfident, like it does help, right? Like Gemini becomes less overconfident, for example. So like you can't push them closer to the basin based on giving them prior historical information or facts. It does not solve the problem necessarily that like they just are really bad at understanding what they're good at. In some ways, like I was thinking about this, there's also like a hard problem because like there are, if they're trained on 20 trillion tokens, any combination of those tokens is some kind of a task or a capability. It is really hard for them to know a priori what all they are good at in some meaningful sense. On the other hand, for some broad subset of questions, shouldn't you be able to say like, yeah, I'm not, I'm somewhat confident. I'm like be a bit better calibrated. It doesn't seem out of the realm of possibility. You should be able to post train this in.
Yeah, it feels like maybe there's an opportunity for your world models to intersect here a little bit and give them
I believe
a
so.
different kind of training ground that, I mean, again, sort of under the notion that we have a lot to learn from non-technical solutions to these problems, right? Like lives and
Right.
careers are really good ways that we figure out this. We fail a lot, we succeed a lot. This is one of my kind of mental models that I use a lot for working with these models is just that, they're a lot like every 22-year-old I've ever hired in that like they're
Yep.
very confident, but also not very they want to show you that they know how to do the work, so they don't want to always ask you questions. They take things as directives when they're probably not fully directed. It's like I
Yes.
think, and if that were an easy problem to solve,
Yes.
it would be solved, right? It's not an easy problem to solve. It takes a lot of energy. We're all still figuring it out, no matter where we are in our careers, and we're all kind of. But yeah, there's something interesting about the concept of like, is there a kind of post training that you could do that gives them that kind of insight? Maybe we need to send them to a psychologist as well to
I mean, we
better
do
learn
need to
about
push them a little
themselves.
bit, right? I had this conversation yesterday with somebody that, like, one of the weird things about the models is that they are incredibly smart. And, it's like somebody gave you like an extraordinarily smart graduate student in your chosen field of discipline, or in all fields of discipline for that matter. You could do paleontology or software engineering or nuclear physics, and like the graduate student is extremely capable and can just do it. However, it is day one of the graduate student kind of showing up at the work, and like for them it's always day one.
Yeah.
So in a weird way, like, they have all of the foibles, but normally with humans you kind of go like that 22-year-old when they show up, you're like, that's fine. I know how to work around your problems for long enough that those problems go away. And the way we work around the problems right now for the models is to create markdown files that they can go look at, which creates a meta problem that now they need to know to go to look at the markdown files in the first place. Like it creates this recursive loop of issues that does not get solved necessarily. We can push them quite a long way, and I'm sure we'll come up with some new breakthroughs that allow us to push them even further. But ultimately, like if you want the models to act in the world with all of us, then we do need them to be sufficiently useful economic actors. And that requires them to have some self conception of their own utility function, or like some self conception of like, this is what I'm good at, this is what I'm bad at, or like, this is what I want, this is what I don't want. Without that, how do you effectively act in any kind of a situation where you need to build something together? It's really hard. So,
Yes.
some version of that is, I think, essential if you want to kind of move towards a world where we have, trillions of agents that are kind of flitting around and actually doing different kinds of things.
Well, that's the other thing actually I was thinking about on your world model stuff is that, it's potentially just an interesting training ground for the models outside of the prediction thing, right? It's just sort of presents, we have to train employees, we have to bring them through the
Yes.
process, they have to get onboarded, they have to, learn about the organization. At my first company, I had a 40-page onboarding doc and ran like monthly meetings for new hires where we
Right.
took them through the history and culture of the company. And again, I think a big point of inspiration for me is the idea that like those are all potentially interesting. There's lots of potentially interesting mechanisms
Right.
here, and we don't know which combination of mechanisms. But I think generally what I think you said at the beginning, which definitely resonates, is like whatever the mechanism is, we obviously need it to be able to operate at a scale that it didn't need to operate at before. So even keeping that 40-page onboarding document was difficult to do, right?
Correct.
And now, like, in a world where you have access to real-time information, these agents have access to real-time information at all times. We need some different. I think that's also why, obviously, there's so many people thinking about memory and different kind of
Hmm.
ways to attack it. Although, I'm like you, I think not super inspired by any of the solutions that exist quite yet. But we'll see where
I mean,
that.
one way to think about it is that, like, no matter how sophisticated your solution, ultimately it is model X plus prompt Y gives you a result in some ways. And the great magic trick we have learned now is that, like, model X plus prompt Y can go in a loop. So, like, prompt Y will make it go in some kind of a loop in order to get to a better result Z. Amazing. And it's super useful and great, etc. But at every given point, I mean, you know this, right? Like when you have an ongoing conversation, you start a new chat on the same project with the agent, you have to start like, hey, dude, like go read this bunch of documents, get up to speed, fill up your context window in whatever way you need, and then we can kind of do work. And at some point, it hits a wall, and then you are the one kind of trying to figure out how to separate things better, etc. Like it's an ongoing process. For some things like coding, I feel like we have enough data in enough RL ability to kind of hack our way around it. But like most of the world is not just directly decomposable in some sense, right? I have this idea
Even
that like
even the coding world is not
e-
directly
e-
decomposable in that. I mean, the
no,
biggest failure mode I see in autonomous coding agents is just fundamental misalignment with the architecture of the application.
correct.
And fundamental misalignment with the request, like not asking for clarification or, making assumptions about where to implement this particular piece of new technology that is completely outside the bounds of the current architecture.
There are these fun, like I have this list. I mean, I'll write this at some point, maybe this week or next week. Is like of the Homo agenticus issues that you kind of see, and some of them are effectively exactly this of like the models quite often love. I mean, they're so scared of getting something wrong that like they love sort of solving a problem that is near what you asked but not exactly what you asked, or kind of go off slightly in a tangent, sometimes by mistake, sometimes just because they think that's the right problem. But like you are sort of sitting there eagle-eyed, kind of going like, did you do the thing that I asked or not? And like what this means is like the errors kind of diverge over a period of time, right? Like so sometimes when you know exactly what you want to build, fine. You can create the end state, verify against it, life is good. But most in software engineering projects, you don't know what you want to like. Nobody wakes up and says, I want to rebuild Chrome, or very few people. You might wake up and say, I want to build a browser, but then like as we saw with Arc and Dia and even Comet or any of these kinds of companies or Perplexity, like the browser you want to build is not like this monolithic, perfect, platonic ideal of a browser that exists. It's like you're trying to build it, you're trying to listen to someone else, build something else. Is that right? Shit, no. We got to rebuild the whole like that loop is the hard bit. And in order for you to effectively act inside that kind of a loop, you need to be comfortable with the fact that you do not know everything, and then you need to solve a part and then be a part of a bigger component and like continuously act as a representative of yourself in order to solve a particular problem.
I just wrote a piece about this for Every, actually, where my core argument, it started with this quip that I really liked, which was that if we're going to call them software factories, we should be
Yeah.
thinking more Warhol and less Ford. And
Yeah.
but fundamentally, this kind of ties up to a lot of the things I believe about agents and why I actually have been doing this podcast is like, I mean, testing is not going to get us the the answer to the problem, because the answers to the kinds of problems we want to solve are not testable, right? I mean, this is
Correct.
like the kind of conclusion I had to that piece is that software companies are actually a much better analogy. If we're going to analogize, they're a much more useful analogy than software factories, because fundamentally a software company has to solve the problem of figuring out what to build and how to build it and why to build it and how to get customers for it. And, at the end of that process, you have how do you deliver bug-free code. But, one of the things I keep coming back to is the idea that like the industry seems to be rediscovering Mythical Man Month,
Yes.
which is 50 something years old or whatever it is, and the idea that like, oh, code was never actually the bottleneck. It was always about like how do you organize agents, and those agents existed inside companies, and they had software engineering titles.
I mean, any time that like you've had needed to get a large number of software engineers to do something, this has been the single, like, what is a complaint that is probably most common amongst entire software engineering world? It's like all the requirements were not good enough for some, like, and this is fundamentally a function of like, no, the real world requirements will never be perfect because a customer doesn't know what they want. It's your job to kind of get them somewhere close, and then they come back and you go back, and it's that iterative process is what you're paying them for, as opposed to sort of getting a perfect final result. Because like, if you knew exactly what you needed, like most of you would need to be here. I mean, I don't know. This is talking about a 22-year-old. I've had this conversation so many times, saying that like your job is not to like get a perfect spec and deliver to it, but your job is to help design the spec so that by the end of the project, both the spec and the deliverable would be accurate. But they both evolve. It's not like the spec just kind of stays monolithic and static. It's like the test suite for a project. You don't start with like a perfect test suite and say satisfy that and then let the models run, which is great. But that's not how a real world works, right? I mean, it requires co-evolution. So, one of the funny things you said about using world models to kind of train, I genuinely think it is true. Because one of the funny things I did, because the world model existed sometime last week, was like, I was like, okay, if I have the world model, presumably this means I can do counterfactuals, or not presumably, it can do counterfactuals. That was the purpose behind doing it. And if it can do counterfactuals, that means I should be able to kind of automatically discover workflows and skills that might be most useful for this particular company. Now, it's not that big, it's like 20% or something. But already, like from the data, I was like, okay, let's try. Go figure it out based on sort of running the sims, and can you come up with something? And it works pretty well. Because guess what? If you have a world model for an enterprise, suddenly things that were super complicated before in order to discover become easier. It's just like, I mean, I say this to people all the time. It's like, if you're the CEO of a company, you don't run your company by reading Datadog logs, right? They're important, but they're way too at a lower level for you to be able to do it. Similarly, if you're running a company with a bunch of agents, or even without, like, if you want to replace your company to be with a bunch of agents, you're not going to replicate that at the log level. You need them to do the job. And that requires like a workflow or skill at a higher level. And so you need to be able to surface that just by plugging something in. So there is I feel like much of this, whether it's on the market side or whether it's on the world model side, it's a reconceptualization a little bit of like, what does an enterprise need to do? And what are the components you need to be able to create such that you get to the end result, as opposed to sort of a correct answer.
I agree. Um, I know you've got to go get your kids off to school, so I'll ask you one
Yeah,
more question about kids, which is, I think we have kids roughly around the same age.
yeah.
How are you thinking about AI with them?
Very good question. So my older son, who's 8, he has grown up with AI effectively, right? It used to be Google Home that he would talk to incessantly and ask questions of. And now he has access to whatever sort of the normal AI tools. The thing that I've seen, like, we have done limited restrictions in terms of sort of, we're trying to do more restrictions, maybe a little bit in terms of screen time, but not really. The core goal for me is that they should be able to use it as much as possible to create things, discover things, and I have no boundary on that whatsoever. For bad, sloppy consumption, I have a boundary. And part of the goal is to try to get them to identify the difference. So an example might be that my older son, again, we during pandemic, we used to create bingo games, like, the 5 by 5, whatever. And he used to be crazy about animals. So he's made like whatever, several hundred bingo games, because he would make them for the craziest subset that that you could think about, like whatever synapse at bingo game with like these 25 ones or whatever, and he would go very, very deep. And at some point he discovered that Canva has an AI mode, which I did not know about. I don't know whether you do. That allows you to, it's a little bit like Replit. It allows you to ask questions and it can create things on the side and websites and stuff like that. So he's been doing that for about a year and a half or something. So he makes games for himself, for his imaginary worlds and stuff. He makes encyclopedias and different things. So this to me is like the best scenario of sort of coding. So like he's doing that, he's building something, he's writing whatever, he's creating images, no problem. Recently, and this happened I think 2 weeks ago or something, he discovered that like for one of his, he wanted to create an encyclopedia for one of his imaginary countries. And when he's creating the encyclopedia of a various sort of dinosaurs that he has kind of conceptualized for himself and its history and evolutionary biology and stuff like that, he discovered that he could just ask the AI to write stuff for him, as opposed to like him writing the whole thing and providing it the input. And then he kind of showed it to me, and there I kind of put a little bit of my foot down, saying like, I don't want to read what the AI wrote. I care about what you made, because it's also not very good. And this is hard to tell because to an 8-year-old, what the AI writes reads very correct, even though it's slop, right? Whereas the thing
To
that
a lot
he
of
writes,
adults too.
no, to a lot of adults too, exactly. Whereas what he writes seems, to him, to his eyes, like, yes, the things are in there, but it's not phrased perfectly or whatever it might be. That I'm trying to separate out. I'm saying, like, use the thing that it's best at, but without losing the spark that you care about. And like, you should never, if the encyclopedia is your output, then you should never let the AI write it for you, because that's yours. And it is, and especially to convince him that like it is not better. I feel like that's part of, this is going to be most of my parenting from now on. But I feel like with kids, they're going to use it. There's no way around it. So like, it is up to you to provide them with the right guardrails and the right on ramps so that they use it for things that they find interesting, and whatever that might be, right? Like might be paleontology, might be music, might be space, might be science, chemistry, physics, art, whatever it is. Like they need to use this as an on ramp to kind of get to the world, as opposed to sort of, and not have it replace the things that are in their heads, their brain. Instead, use it as a extension of capabilities that they just don't have at the moment. I think that works pretty well so far. I mean,
Yeah,
let's talk again regularly so that we can come
yeah,
back.
we definitely we need a group chat for parents of kids who are trying to figure this out. I've been very focused with my oldest on encouraging her to develop her own voice, similarly to you, because
Yeah,
I feel like, and again, my take on a lot of this stuff is like the AI is really just reflecting sort of societal things
right.
to us. I think this is also a failure of education. I think that a lot of education is trying to get kids to write in the same way. And
Yeah,
to me, what makes a good writer is that they've figured out that they write like them, and you're reading
correct.
them. You're not reading the generic version. And so that's been my big focus. Well, listen, I really appreciate you joining today, and this was a great conversation. I'm sure we could have
Right.
another hour, but thanks again for.
Easily. My absolute pleasure. I see that one of them has actually gotten up, so now I do need to run.
Okay,
Pleasure, man.
pick
This
up the
was
school.
wonderful, Noah.